Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. By now, you know about distributions, variance, p-values. So if your question is, why did we have to go through all of these videos? The most simple answer is, well, because you'll be doing a lot of what we call hypothesis testing. So for you, then the follow-up question should be, what is hypothesis testing really? What do we test with it? In this video, I'm not going to teach you how to run a test. I'm just going to explain what kind of a problem hypothesis testing is trying to solve. This all starts from the main fact that we have iterated in a lot of the previous videos, is that we almost never observe the population. We observe one random sample. And as we've mentioned, that sample is noisy. So sometimes we will see that the relation between two particular variables we're interested in could be true. The thing is, we will almost never estimate exactly zero as the kind of relationship. So the problem is not about did we get a zero or did we not get a zero for that relationship. The problem that we have is what we observe plausible under a world with no effect? Think of hypothesis testing as a thought experiment and start from the statement. Imagine a world in which a specific statement is true. This specific statement is what we will call the null hypothesis. Okay, examples would be the coefficient is zero, or the policy has no effect, it could be the variable doesn't matter in the relation. So after that, we can ask, if this world were true, how likely is the data we just observed? And I'm going to put this in a different color because this is basically the whole intuition behind what the hypothesis testing is doing. If this world were true, how likely is the data we just observed? Because samples are random, the same model can generate many different estimates, okay? Some will be close to zero, some will be very far away, some will be off by very little. Probability, which is why we learned the previous videos, tells us which outcomes are typical, which outcomes are rare. And hypothesis testing uses exactly this idea of rarity that the probability made available for us. Hypothesis testing does not prove, okay? Does not prove if something is true or false. Instead, it asks, is this result too extreme to be explained by randomness alone? And if the answer is yes, the null suggests to explain the data. If the answer is no, then that just means the null remains plausible. So that's all hypothesis testing ever does. Now, because we can't see the population, hypothesis testing forces us to make decisions under uncertainty. That's why we need to use rules, thresholds, conventions. So not because they are perfect, but because doing nothing is worse, okay? And this was the whole reason why we learned how to read the t-table, the z-table, and so on, because these are all crucial tools where we get to that point that we have to take that decision. Also, everything we've just said is conditional. Conditional on the model being correctly specified, conditional on the assumptions needed for inference holding, for which we had a whole mini arc on its own with videos. And this is also the reason why diagnostics matters. And this is why when we did that nice checklist of things you need to know about OLS, issues with OLS was something that we said we're going to look into very specifically. So hypothesis testing is only as good as the model behind it. The last key takeaway out of this video is just a reminder, hypothesis testing is asking whether the data we observe would be rare if a particular story about the world were true. And again, this is all conditional on the model being a good model. Now that you know what hypothesis testing does, I'll see you in the next videos to see how exactly we run hypothesis testing.